Okay, in this segment we are going to be looking at the one transistor dynamic RAM cell. A quick introduction before we begin. Computer memory, as we know, is made up of random access memory or RAM and read-only memory or ROM. Within RAM there are two subtypes, static RAM or SRAM and dynamic RAM or DRAM. So in this segment we are going to be looking at one of the dynamic RAM cells, which is the one transistor DRAM or 1T DRAM. So before we actually go into the circuit diagram and what this DRAM cell is made up of and so on, let's look at some of its features. So compared to your 6 transistor static RAM cell, the 1T DRAM cell is first of all easier to install. Secondly, it is less expensive. So these are its advantages. But on the flip side, its disadvantage is that it needs to be refreshed regularly. So what do I mean by refresh here? As you can see from the circuit diagram, there are a couple of capacitors which we are using in this cell. We will be studying the construction in detail in a minute, but even without knowing that, you can see that the circuit diagram has capacitors. And if you remember, a capacitor is a device which stores electrical charge, and with time the charge keeps getting drained. So the moment my capacitor is drained of its entire charge, I am going to lose the data stored in this cell. So if I want to retain data, I have to keep charging the capacitor at regular intervals, and that is what I mean by refreshing the cell regularly. So a one transistor dynamic RAM cell needs to be refreshed, or the capacitors needs to be charged every 64 milliseconds. So that is a very frequent interval. So that is a drawback. But the advantage is that they are easy to install and they are less expensive compared to your static RAM cells. Now we will take a look at the structure, the working, how to perform read and write operations. So your dynamic RAM cell looks like this. First of all, there are two lines, WL and DL, which represent the write line and the data line. Write, WRIT, write line, and the data line. So these are binary values. So if current passes through the write line, we say WL equals 1, and if it is turned off or there is no current flowing through it, we say WL equals 0. The same applies to data line. If some voltage is flowing through it, some data is being transmitted, we say DL equals 1, otherwise the DL is a 0. Now these two, there is no connection at this point. There are just two lines. And from the data line, we have a transistor connected. This M refers to the memory cell or the transistor. This transistor over here is connected to capacitor 1, and on the other side it is connected to capacitor 2 and also through the data line. So how is any piece of information stored in this dynamic RAM cell? So this C1 is a capacitor. If it is fully charged, we say the data stored in the cell is a 1. If there is no charge, if the charge is emptied, we say the data stored is a 0. So any data in a dynamic RAM cell is stored in terms of the contents of the capacitor, which is why as the capacitor keeps draining itself, the data is going to become lost, which is why you need to keep recharging the capacitor. That is what we studied over here. So let us take a quick recap of the structure, and then we'll look at the working, which will help us understand this better. So we have two lines, the write line and the data line. If current is flowing through either of them, then the respective line is said to be high or 1. If not, it is a low or a 0. The data line is connected to a transistor. The transistor on the one hand is connected to a capacitor C1, which is responsible for data. So if C1 is fully charged, we say the data stored is a 1. If it is empty, we say the data stored is a 0. And on the other side, the transistor is connected to the data line again, and the data line is again connected to a capacitor C2, which is sometimes called the column capacitance. Now there are two operations, write and read, which can be performed on the cell. The write operation, again we can split it into writing a 0 or writing a 1, because of course all data in the cell is binary, so everything is going to be in terms of zeros and ones. So we'll look at each of these operations one by one. Let us start with how to write a 1. So if you want to write a 1 onto this DRAM cell, meaning I want this DRAM cell to store the value 1. My first step is to set both the WL and DL, that is the write line and data line, to 1. So like I said, these are two binary values, they have switches. You turn on both the switches, both write line and data line. So what happens is, this write line here, it sort of acts like a switch for this transistor. So whenever WL equals 1, this transistor becomes on. So the moment I set WL equals 1, this transistor becomes on. And what is the purpose of this step? It is to tell the memory that I am going to perform a read or write operation from this cell, because your memory is made up of an array of numerous cells like this, right? And each cell has its own write line and data line. So when I want to read or write from a particular cell, I need to first select that cell. And to do that, we set the write line of that corresponding cell as 1, write line. So which is like switching on the transistor corresponding to that cell. So to write a 1, that is the first step. We also set the data line to be 1, meaning we are also switching on the data line. So now what happens is, charge flows from C2 to C1. So when you set the data line to be a 1, the voltage here is high. So charge and the voltage here is low. So charge flows from C2 to C1 and C1 gets filled up. So when C1 is filled up, so C1 is high voltage and we know that is called C1 carrying a 1, right? So that is how we write a 1. So what if I wanted to write a 0? I would still set my write line to be 1 because I want to select this cell, but I would set my data line to be 0. So write line would still be a 1. This transistor is being switched on because I am going to use this particular cell. Now I would set my data line to be 0. So what happens is, C1 discharges, because now C1 contains some charge. If it is a 1, it's high. If not, let's say the charge is slowly decreasing, it's some non-zero value. But at this point DL is 0, so the voltage over here is 0. So charge flows from C1 to C2 until C1 is empty, it is devoid of charge. So now C1 has become empty, meaning C1 now carries a 0. That is how we perform the write operation. So we will recap the write operations and then move on to reading. So if I want to write a 1, I first set my write line to 1, thereby switching on the transistor. Then I set my data line to 1, facilitating the flow of charge from C2 to C1 until C1 is fully charged, meaning C1 now carries a 1. If I want to write a 0, I again set my write line to 1, switching on the transistor, but I leave my data line at 0. So charge flows from C1 into C2 and C1 becomes empty, which is what denotes C1 carrying a 0. So that's how I write. Now let's say I want to read. How do we perform the read operation? Again, the first step is always the same. We set the write line to be 1. Now you might ask me, why are we setting the write line to be 1 when we want to perform a read operation? So the answer, like I said, is the write line, it is just called the write line as a naming convention. It does not tell you whether you are reading or writing. It has got nothing to do with what operation you are performing. It only acts as a switch which helps you select which cell you are going to be working on. Because my memory is made up of multiple cells. So if I am going to work on this cell, whatever I am doing, this cell needs to be selected, whether it's a read or write 1 or write 0. So my first step across all three operations would be to set the write line 1, thereby switching on the transistor. So that is this step. Now C2 should be charged up to VDD by 2. C2 is our column capacitance here. We charge it up to VDD by 2, where VDD is the maximum charge that this C2 is capable of holding. So what are we doing? We are charging this to half its maximum capacity. And why half? We will see now. So what are we trying to do here? We are going to read. So whatever value is in C1, we want to read and obtain it, right? So the value is either a 0 or a 1. Whatever it is, we want to obtain it along the data line. So now C2 is charged to its half capacity. So let us assume C1 is a 1. Charge flows from C1 to C2. The data line carries a potential greater than V and the output would be a 1. So what does that point tell us? So now C2 is charged to half capacity and C1, let us assume it carries a 1, in which case this is fully charged, right? This one is fully charged. this one is half charge. So current flows from here, from C1 to C2, or charge flows from C1 to C2. Now what happens here is, you already had some V by 2 charge and more voltage is flowing through DL. So the voltage across DL increases. So it becomes greater than V, where V is the maximum. So when the voltage increases, DL gives the output as 1, which is exactly what we had here. On the contrary, if our C1 had a 0, charge would flow from C2 to C1. The voltage across DL would decrease, so the output would be 0. Let's look at that case also. Let's say this one was a 0. Now this has no charge, this one has some half charge, so still the charge is higher here. It would flow from C2 to C1, so the voltage at this point is going to decrease, so DL will give me a 0 output, which is what we had at C1. So that's how we perform a read operation. So we'll quickly recap the reading operation. We first set the right line to be 1, thereby turning on the transistor. We charge the column capacitance to half its maximum capacity. Now if this one had a 1, meaning this one was fully charged, charge flows from here to here, the voltage at this point increases, so the output on the data line would be a 1. Whereas if this one was a 0, it had no charge, charge flows from here to here, the voltage at this point decreases, so the DL would output a 0, and the output of whatever is here comes at DL. So you can then take it and connect it to an adder or subtractor or whatever you want and perform the operations required. So that is a dynamic RAM 1 transistor cell for you.